recapitulate that. We have talked about basics of probability, and now what is
Yes, ma'am.
there is uh, because probability involves outcomes, number of outcomes are very important,
Hmm.
and permutation and combination play a crucial role. So, what we are going to do, just to calculate number of outcomes in various situations, we are taking up permutation and combination so that we can simply put in the probability formula and get the right answer. Is this fine?
Yeah.
Now, how does this work? When it is permutation, then we know it is arrangement. And
Permutation means arrangement.
huh?
Permutation means arrangement.
Yes, permutation means arrangement, and we do it whenever we have different objects. So, for example, I have a maths book, I have a chemistry book, I have a Sanskrit book, and I have to arrange in the rack. So, of course, order matters. So, wherever order
Yeah.
matters, we have to take care of permutation. We need to apply permutation. And that means out of n objects, if you want to arrange r objects, the formula is n factorial upon r factorial.
Okay. Okay. R factor.
So n out of
This is a
r,
formula permutation.
yes. But when we, sorry,
This is a formula permutation.
what do you think permutation is? We need to arrange
Mhm.
objects, n objects out of r.
R objects.
Yeah. So this is the formula
Yeah,
for
got it.
permutation. Now, when we say
Okay.
combination, combination means when you want to select. Now, selection means, let's say you have a committee of 5 people and you want to nominate two of them to, take care of some responsibilities. So, whenever selection is there, that you are choosing somebody, preference is given to someone, then we apply
Okay.
combination. And combination, it has major role to play in binomial expansion also. What do we do?
Okay.
N factorial over R factorial. That means permutation is there, but
Okay.
then we have N minus R factorial objects also out of which we can choose. Like what is happening? We have 5 people out of which 2 people have to be selected. That means what can be the selection criteria? 5 factorial and 2 factorial are here, which
Hmm.
you have to arrange those people also whom you are choosing, right?
Yeah.
If you have 5 places, one,
Okay.
two, 5, you only want 2 of them to sit, but order matters. Whether they are sitting together, whether they are sitting here, or they are sitting here. That arrangement of 2 people will give you 5 factorial over 2 factorial. You need to
Okay.
choose. You need to choose 2 people out of 4. But it also
Okay.
involves arrangement of those two also, because those two are not same. If I'm saying people,
Hmm.
one is Akansha, one is Astha, but these two A's are not same. One is A1, another one is A2. So I'm choosing, that is
Yeah.
fine. I'm using 5C3. But why permutation is also required? I'll use 5 factorial upon 3 factorial and 5 minus 3 factorial.
For the arrangement.
Yes. So the arrangement is for 3 people, and then you have to see the position of other rest of the elements also in order to arrange those people accordingly. Does this make sense?
Yeah. Then what's the best way to understand in which question can we use permutation, which question can we use combination?
You know what? You will yourself apply induction method. We are taking up some of the examples, and you will see. Firstly, the keyword is the key. For example, whenever arrangement keyword is used, you have to use permutation.
Hmm.
Whenever selection
Okay.
or chosen or choosing word is used, is used, then you have to choose combination. Okay.
Okay.
Apart from
Okay.
that, you will see that what is happening. So first of all, do you know how to expand this factorial thing? For example, I have
5 into 4 into 3 into 2 into 1.
correct. If I have n factorial, this will go in decreasing order up till 1. And
Yeah.
0 factorial is 1 only. So if I have 5p3, formalize this for permutation. So 5 factorial upon 3 factorial, okay?
3 factorial. Okay.
So that means, just bear with me, 5 into 4 into 3 into 2 into 1, I'm not writing. I'm just simply giving it a full stop with 3 factorial, okay?
Okay. Yeah. Because it will
Why?
cancel out.
Correct. So can you see the
Thank
relation
you.
between NCR and NPR? This is the formula of NCR.
Yeah.
Now, it has n factorial upon r factorial, which is NPR, right?
NPR. Yeah.
And then you have n minus r factorial. So this is the relation. Okay.
Okay. Okay.
Also, you will see that always, okay, if I have to do 5C3, what it will be?
Yeah. 5 factorial by 3 factorial into 2 factorial.
Correct. So 5 into 4 into 3 factorial.
4, 2
This is
factorial.
2. 2 to the 4, 10.
Yeah. 10.
10 ways are there through which I can choose 3 people out of 4. Maybe I
Yeah.
have A, B, C, D, E. I can choose A, B, C. I can choose
Okay.
B, C, D. I can choose C,
Okay.
D, E, A, C, D, and so on, right? So these are
Hmm.
10 ways how we can do it. This combination is also used in binomial expansion. When
Okay.
I have to take up, for example, you know what is x plus y whole square?
Yeah. X square plus y square plus x square.
Correct. So this is the formula which we have learned in our previous classes. Similarly, this is 3xy, x plus y. But
X
what if
plus
it
y. Yeah.
is x plus y raised to power 50? Then how will we do that? Then we use combination. So this is binomial term. Why? Two elements are there, two unlike terms, right?
Yeah.
Now, if I have to solve it, a plus b raised to power n, you need to do NCR,
Okay.
a raised to power, you will start with full a raised to power n, and with
Okay.
no b.
Okay. Got it.
And then you will keep decreasing a and keep increasing b. So it will be,
Okay.
you will start with 0 because it is like n 0 to r, in fact,
Okay. Got
0
it.
to n, and you will
0 to.
have this NCR. This R is going from 0 to n, NCR, A raised to power n, and B raised to power R. Okay? So you will keep increasing. N, this will become, this is NC0. Now the coefficient is
Uh,
NC1, NC2, and this is A
it
raised to
will
power
go
n.
till it will go till 50.
Yeah, here it will go till 50. Otherwise, in the general form, it will go till NCN.
And
Now,
Cn.
A will not be there and B has whole power. So
Okay.
NC1, A raised to power n minus 1, B raised to power 1. Then you will again
Okay. Got
decrease.
it.
Yeah.
N2 B2. Okay. Got it.
So if I have to expand this, what I'll do, 50C0, A
Yeah.
raised to power n,
It
Y raised to power
X
0 is
50.
Y. Sorry, 1.
Yeah.
50C1, X raised to power 49 and Y. 50C2, X raised to power
Yes.
48 and Y square. And so on. X raised to power 0 and Y raised to power 50. So this is how we get this
Okay.
one also. This expansion is also done this
Okay.
way. Uh, you know how to solve it, right? Also,
Yeah.
NCR is equal to NCN minus R. This is one corollary. So if I'm doing, you can test it. If I have, let's say 50C50, and if I have 50C0, here N is what?
Okay.
50. R is what? 50.
Yes. Yes.
So here N minus R becomes 0. I have considered N as 50, R as 50. So what is my NCR?
Okay.
It is 50CR, 50C50.
50 CR. Yeah.
And what is my NCN minus R? N is
50
here,
C0.
right?
Yeah.
Let's check whether I'm
Yeah.
getting the same answer or not. So you'll see this is 50 factorial. The formula is NCR, N factorial upon R factorial, N minus R factorial.
Okay.
So 50 factorial upon R factorial into 50 minus, right?
Yeah.
And here the expansion will be 50 factorial, 0 factorial, 50 minus 0 factorial, right?
Yes.
So see, this is gone. Only 0 factorial is left, which is 1. Then
Mm.
50 minus 0 is 50. This is 1, 0 factorial 1. So you can see this result holds here. Okay.
Yeah.
Let's come back to the questions now. How to see whether it is a question of permutation or combination. Read this.
Miss Jones has 10 books that she is going to put on a bookshelf. Of this, 4 are mathematics book, 3 are chemistry book, 2 are history book, and 1 is a language book. Miss Jones wants to arrange her books so that all the books dealing with the same subjects are together on the shelf. How many different arrangements are possible? Arrangements. Permutation.
Yes. So, first of all, you need to check 10 books are there. So, if 4 are
Yes.
mathematics, they can be arranged in 4 factorial form.
Yeah.
Because, of course, if those are 4 books and they are in the bookshelf, every book will be having different what is it called? Index number. Like, the library
Mm.
has a particular identification number. So, no book will
Yeah.
be having same until it is pirated one. I mean, the copied breach of intellectual
Mhm.
property. Otherwise, they are different. So, 4 factorial. Then for chemistry books, it will be
3 factorial.
3 factorial. For history books,
4 factorial.
2 factorial, 1 factorial. Now, the thing is, these are separately indexed, but she
Yeah.
also has to arrange her books, same subject together on the shelf. So that means 1, 2, 3, 4. 4 other arrangements are also required because let's say she has put maths book on the first in the first row, chemistry books here,
Yeah.
history books here, and language book here. But these 4 has their different arrangements. Chemistry can go first, maths
Yes.
can go second. So for that, you need to apply 4 factorial.
Okay.
This is for arrangement of rows, and this one is arrangement of books in a row.
Okay.
So this is how we can solve it. Is it clear?
Okay.
No?
Yeah, I got it now.
Okay. Question number 2.
So that's the answer. 4 factorial into 3 factorial into 2 factorial into 1 factorial.
Yes, question has only asked the number of outcomes. How many different
Okay,
arrangements are
got it.
possible?
Okay, got it.
Then you can use calculator to solve it. Yeah.
Okay, got it.
Now there is another concept. Question has asked me different letter
How?
arrangements can be formed.
Yeah.
Can you see this is pepper? And let's say if it would have been people, one, two, three,
Yeah.
four, five, six, then of course
Hmm.
those must be having different names, different identity. So I need to write it
Yeah.
this way: P1, P2, P3, E1, E2, and R, right?
Yeah.
Then every person must be having what different sort of arrangement would be 6
Yes.
factorial, right?
Yeah.
6 factorial. But if you see, I have here three same letters and two same E's.
Yeah.
And for them, order doesn't matter because they are
No.
identical. Order only matters for those which are non-identical.
Non-identical.
So if they are identical, then I need to divide their arrangement out of it. For example, you will do 6 factorial, but you will divide for those arrangements which are repetitive in nature. For those for whom order doesn't matter. So 3 factorial for same p's and 2 factorial for
Yeah.
same e's.
Factor for same is.
Is this fine?
Then why not R?
Huh?
Ma'am, why not R?
R is single. R is not
Oh
repeated.
yeah.
So 1 factorial, even if you write, that is 1 only, and it is, so we are not dividing it. We only
Got
need
it.
to divide it with those arrangements which are repeated in nature. If this
Repetitive in
would have
nature.
been the condition, then we would be having what? 6 factorial for these 1, 2, 3, 4, 5, 6, and then 3 factorial for different p's and 2
Different
factorial for
P.
different e's, right?
Is. Got it.
Okay. So you can solve it 6 into 5 into 4, 3 factorial.
Into 3 factorial by 2.
Oh, 3 factorial is gone, right?
It's gone, yeah.
Still. Read next one.
A chess tournament has 10 competitors, of which 4 are Russians, 3 are from United States, 2 are from Great Britain, and 1 is from Brazil. If the tournament results lists just the national list of the players in the order in which they place, how many outcomes are possible?
Now tell me,
Combination.
uh, outcomes are possible. They have to arrange this in order, right?
Oh, yeah.
So permutation needs to be applied, but how? What do you think?
This will be permutation.
This is permutation. Why? If you
Okay.
read this question, chess tournament,
Yeah.
it has 10 competitors,
Yeah.
and then out of which 4 are Russian, 3 are from
Russians.
US, 2
Yes.
from Great Britain, and one from Brazil. And when result will come out, they have put in the condition. How are they going to display the result?
In the order in which they are placed.
But are they considering that if there are 4 Russians, I'm going to put it by name because 4 people are different. So let's put it ranking by name or something. Have they put any condition like
No.
that?
No.
So what is the condition?
They have to place by the rank.
By the rank of nationality.
Yeah.
That means they are treating 4 Russians identical. They are going to just put in the
Yes.
result that first Russia, second Brazil, ranking in as per the nationality.
Yeah.
So that means this is not the case of non-identical being. Just like we had this maths, chemistry, and this all those sort of books, they asked me to find out different arrangements. So we simply put this when order matter. But here, order doesn't matter. They are
No.
repeating, right?
Yes.
So what do you think will be the answer? Number of
I think
outcomes. How many are total?
uh, 10.
So that means 10 factorial. It was supposed to be 10 factorial. If
Yeah.
um, no repetition or something like that was allowed. But now, because repetition of of identical being are happening, so I need to divide the arrangement. This is 4
Mm.
factorial, 3 factorial, 2 factorial, and 1 factorial. Does this make sense or not?
Yeah.
See, if question would have asked me that tournament results list not the nationality, but the people, I mean the players, as per
Yeah.
their performance, then that means those 10 competitors were like R1, R2, R3, R4, US people U1, U2, U3, Great Britain
Yeah.
G1, G2, G3, and
G1,
Brazil
G2.
B1, B or B1, right? So
And
10
Great Britain
people,
are just two
huh?
players.
Sorry, oh,
Great
two,
Britain,
yes,
there are only two players, man.
yes, yes. So
Yeah.
that means 10 factorial total arrangements. But
Yes.
then they also have their specific arrangement that who has,
Specific arrangements.
yes, who has come first out of Russians. They will also,
Exactly.
celebrate their ranking in their country. So this will be 4 factorial, 3
4
factorial.
factorial into 3 factorial into 3 factorial into 1 factorial.
But now, because they are identical, so this will not go in multiplication, instead in division form.
Got it.
So this is the answer, and you can solve it, right? Tell me what it will be.
Um, I have no calculator with me right now, so it will take some time.
Okay, chalo. ठीक है. Read
Um,
this question.
how many different signals, each consisting of 9 flags hung in a line, can be made from a set of 4 white flags, 3 red flags, 2 blue flags, if all flags of the same color are identical?
Now, different is also the keyword. Different
Okay.
signals is also the keyword for permutation. Okay. When there is not
Different.
choice that you have to choose and without any condition, just choose. It is, they
Okay.
are asking, they have put in the condition that those have to be different. Okay. So permutation. What will you do?
Okay. 9 flags.
Hmm.
9 factorial by 4 factorial into 3 factorial, 2 factorial.
See, for 9 flags, it is 9 factorial. Now, 4 white flags, they are identical. So,
Yeah.
what you are going to do? Divide.
Divide. Exactly. That's what I said.
Yes, that's right. Read it.
A committee of 3 is to be formed from a group of 20 people. How many different committees are possible?
Now, this is like committee has
Combinations.
to be formed. and three people. Those three
Oh, no, it's
people,
permutation.
it's what?
Is it permutation?
Okay. How do you think that it is permutation?
I mean, you said different is also a keyword for permutation.
So different arrangements, and also when we see the last thing, a different signal was there can be made from a set all flags of the same color identical. When this bit has been mentioned identical or non-identical, and here it was if the tournament results, how many outcomes are possible? The order was the keyword. Here,
Yeah.
arrangement was the keyword. Arrangement. Now, when you have to, this is literally translating to people have to be chosen. Committee will be formed. Three people have to be chosen. This is what it is giving you some idea about. Tell me if not.
Oh, that's how many possible? Uh, 20 or 20 is total, right?
There
Uh,
is a group of 20 people and committee of three people have to be formed.
okay,
So which means how many committees are possible. So it is like the formation of a group, and then you
yeah,
have set of three people,
okay,
and this set of three people, how many of they will be there? How many people the set will be there? So it is like you are choosing those people, and this is the game of choice.
okay,
Committee people, there is no arrangement or order, which is they are not saying that how many different committees and their arrangements are possible. Okay, so this is the
okay.
game of choice. So what you will do? It will be 20C3.
Combination.
Yes.
Okay,
Combination can also be written in this way. Only bracket 20C3, I mean 23. That means this is N, this is R. Total and the
okay.
choices. Okay.
Just right.
I know this is a bit confusing that you could not identify
Yeah.
whether it is permutation, combination. Let me give you a robust plan. Let's go further and then we'll talk about it. I'm putting it
Okay,
so that you
great,
can,
great.
until you yourself could identify, I'll not move further. Yeah, don't worry.
Okay,
So this is 20C3. So it is 20 factorial, 3 factorial, and 17 factorial. 20,
70 better.
19, 18, 17 factorial gone. It is
Gone, yeah.
3, 1. So what it will be? 6 3s are 18, 19 3s are 57.
Yes.
It will be solved. Now read this.
Okay. Form a group of 5 women and 7 men. How many different committees consisting 2 men and 2 women and 3 men can be formed? What if two of the men are feuding and refuse to serve on the committee together?
Now again, whenever
Okay.
there is,
What?
I mean, from these two questions, we can say that when it is the question of people and when committee is forming, so that is something we can bring it down to choices. Okay.
Yes.
That you have to form a group. This is also a question of combination. Five women,
Mhm.
7 men are there. You need to
Okay.
choose two women and three
Mm.
men. So how would you do that?
Yes. Uh, a 5 seat 3 and 7C2.
5C2 and 7C3, right?
Oh, sorry. Yeah, yeah.
So this is the answer for the first part.
Yeah.
Now, what is it saying?
What if two of the men are feuding and refuse to serve on the committee together?
So these two people, I mean, from the men group, they
Hmm.
have a clash and they don't want, they have just
Yes.
said that if he's going out of these three men, because committee will be having three men, if he's going, I'm not
Yes.
going. So this is a
Okay.
bit complicated. Now see, if I, just like we have, if I have to find out probability of x greater than 3, so greater than
Hmm.
3 can go till infinity. I can simply find it with 1 minus p x 0, 1, 2, and 3, right? It is easy. What I'm saying, this is this is
Am I
the,
writing something?
yes, can't you see?
No, no, I can't see.
Hold on, why it's happening?
Oh, yeah, I can see. I can see. Yeah, yeah, I can see.
Huh. So I'm saying, let's say you have to find probability of expansion of the choices when x is greater than 3. So
Okay.
instead of finding out it for outcomes greater than 3 means 4, 5, 6, and so on up till infinity, can't I do this way?
Mm-hmm.
1 minus 0, 1, 2, 3. I know that
1 minus.
probability of an event and not happening of
Yeah.
an event is 1, right?
Yes.
So if I have to find out probability that the value is greater than 3, and I know this 3 is okay, let me have these discrete value. I have values till 10. I need to find
Hmm.
out probability that x is greater than 3. The value is greater than 3.
Okay.
So instead of
Okay.
counting this way, can't I do that 1 minus when x is less than 3? This is
Yeah.
happening of an event. This is not happening of an event, right?
Happy opening with that. Yes.
So that means it is simply 3 by 10. 3 by 10 for this one. 1 minus 3 by 10 means 7 by 10, right?
Yes.
So, why I'm
3
telling
by
you
10 is
this,
the happening of the event, right?
3 by 10 is not. Because that
Oh, not happening of the event.
question has asked me greater than 3.
Okay. 7
Are you
by
getting?
10. Yes, got it. Yes, I'm
Yeah.
getting.
So, now what I'm thinking that I need to make a group, a committee of 5 people.
Yeah.
These 5 people will be having what? Uh, 2 women and
Yes.
3 men.
3 minutes. Okay.
2 women and 3 men, right?
Yes.
So if I say these 2 people who are feuding, who are having a clash, if I group them together and then subtract from total, that is also one way.
Yeah. Yes.
So if I'm grouping them together, that means what is the combination? 5C1 out of
Mm.
these 5, I have 2 people together. Those two,
Yeah.
so women will be 2 out of 2,
Mm.
right?
Yeah.
But then those 2 people are grouped together and considered as one entity. Is this
Yes.
fine?
Okay.
So this is what, this is something, a total when, if they are together.
Okay.
So that means 5 factorial, 1 factorial, 5 minus 1, and 2c2. Whenever it is NCN, it will be 1 only. Why? You can
Okay.
see this is all gone 1. So I have 5 ways. If you solve this, you have 5 ways
Yeah.
because 5 into 4 factorial, it will be taken down. 5 ways that they'll be together.
Yes.
That means out of these 7C3, 7C3 is the arrangement for men.
Yes.
I need to take away these 5 ways so that they cannot be together,
Okay.
right? So 765 into 4 factorial. So this 3 factorial is 3 to the 6, so 6 gone, 35. That means 5 ways of having them together, 35 ways of total. So then they will not be having, the position in the same committee. 2 men having clash, not in the same committee. That will be 35 minus 5, that is 30 ways, right?
Okay.
Tell me, do you want me to explain this again?
Yeah, ma'am, please.
Sure. See, what it is saying that this is something. 5 women and 2 women. Out of
Yeah.
5, 2 women have to be selected. And out of 7, 3 women have to be selected. Right?
Yes. Yes.
So I have considered that this is the total and first part is done. I am hoping that till first part you are okay.
Yeah.
Now, the second part is saying that 2 of the men cannot come together. So for that, I need to remove them from the arrangement of men. Initially, it is how much? 5 factorial, 2 factorial, 5 minus 2, 7 factorial, 3 factorial, 7 minus 3. So
Yes.
5 into 4 factorial. 4 factorial will be gone. Then 7 into 6 into 5 into 4 into 3. This is 2. 3 to the 3 to the. This is gone. 3 to the. This is gone. 2 to the 4. So 350 is the answer. 350 are the total
Yes.
ways that committees can be formed. Now,
Got this. Got it.
out of these 350 ways, I need to find out that how many ways can be there when those men cannot be together. So what I'll do, it is, let's find out when 2 men are together. And then, because I have to take 3 men out of 7 men. Firstly, I'm sorting
Yes.
the men's choices. Okay.
Yes.
So total choices in which men can form the committee is 7C3,
Mm.
right? 7 into 6 into 5, 4 factorial gone, 3 2s are 6. 35 ways are there in which men can form the committee.
Yes, ma'am.
Huh. So if you are, and my screen is visible, this no one note.
Yes. Yes. Yes.
So if you are keeping those 2 men together, you are choosing both of them together, then what you are left with? That means 2 are here, total 7
Mm.
people. This is the 7C3. So 7,
Yes.
2 out of 7 are here. So how many are left? 5.
Mm.
3
Yes.
out of 2 are here. So how many is? 1.
One.
So this is the combination when you are considering both of them together,
Yes.
and one person you will choose out of these 5. So it is how you
This
are
one. Yeah.
making 7C3. So this is
Got
one.
it.
5 factorial 1, 5 minus 4. This is 5 ways. If I solve this, it is giving me 5 ways answer.
Hmm.
No.
Got it.
Now, you don't want to keep them together. So that means just subtract these 35 minus 5. 5 ways for them being together.
Hmm.
35 is
Hmm.
total. So 30 ways those men can be selected in the committee, right?
Yes.
But then this is the answer how men have to be there. But we have females also.
Hmm.
And those are how many? 5C2. We don't have any condition for them. So those will be
Yes, ma'am.
5 into
3
4, 3
factorial 3.
factorial gone, 10 ways. So
10
now you
ways,
can
yeah.
use the counting principle. 30 into 10, 300 ways of forming
100
a committee.
ways.
Is this fine?
Yeah.
So, you will be asked to find out probability, but for that we have to find out what um, the outcomes, number of outcomes. You got it?
Yeah. Yes.
Let's say you have um, a police department in a city, okay?
Okay.
And it consists of 10 officers.
Okay.
Now, what will happen? It is the condition that if there's a policy of department that 5 officers will go on patrolling job,
Okay.
and then 2 of them will work in office full time at the station,
Hmm.
and 3 of them will reserve the station.
Okay.
3 will be in reserve that if emergency comes, they'll move, and 2 of them will be on duty at station.
Okay.
And you have 10 officers. Yeah.
Okay.
So tell me how many different divisions of those 10 officers can you form into 3 groups?
3 groups. 5 factorial into 3 factorial into 2 factorial by 3 factorial.
So first of
No.
all, you tell me this is the condition of what? Permutation or combination?
Second.
How many different divisions of the 10 officers into the 3 groups are possible?
Uh, Permutation,
Yes. Are you? So why it is not combination?
because there's no choice in this.
Yes. There's no choice, and we are actually arranging them. There can be
Yeah.
maybe 3 people have to be chosen. 3 people have to be arranged. One can go patrolling, one can be from reserve, one can be from station.
Yes.
Then next time that another person can go, and then we have different arrangements. Now
Yes.
it is like we are not arranging them with their name or something. It is like you have to take those patrolling officers are 5, and you have to take for patrolling from those 5 only.
Okay.
Reserve will be from 3, at station will be those 2. So what do you think? This is the case of identical or non-identical?
Wait a minute. Uh, Identical.
Identical. Correct. So tell me what's the answer?
5 factorial into 3 factorial into 2 factorial. No, 10 factorial by 5 factorial into 3 factorial into 2
Oh,
factorial.
perfect. Perfect. That's what I wanted. So tell me the answer.
10 factorial 5 10 million. 5 factorial will cancel out. Uh, 16 into 7. 2520.
Right. Now you have 10 children
Okay.
and they have to be divided into two teams, A and B.
Oh, okay.
These 10 children are to be divided into team A, team B. And this
Okay.
team will be having at most five people, team of five each. A team will play in
Okay.
one league and B will play in
Hmm.
another league. Tell me how
Okay.
many different divisions are possible?
Total how many players?
How many divisions are possible? So this team will play in one league and this will play in another league.
Okay.
So how many different what do you think? How many different divisions are possible?
10, 20. I'm not getting this question honestly.
Basically, there are 10 children
Okay.
and they are not given choice that you choose one team. They are to be
They're given a
divided.
choice.
No, they are not.
Okay,
It
they're
is
not given a
like
choice,
you
obviously.
have to divide. They are to be divided into team A, team B.
Okay.
Team A and team B. So, how many divisions are possible of those people, those children?
5 each.
Five each. See, total there are 10
10 is
factorial
2.
ways. So, it is not a question of choice. They are not like
Oh, yeah, yeah, yeah.
they are
Oh,
to
yeah,
be divided. So, this
permutations.
is permutation. 10
Hmm.
factorial is the arrangement for those 10 children. Now, because
Yeah.
they are identical, we are not seeing that particular, it is about different league. It is the case of
Hmm.
identical thing.
2.
Anybody can go anywhere. So 5 factorial and 5 factorial. Does this make sense?
Okay. Yeah.
If I give you another example, you ha- in order to play a game of basketball, again, 10 children at a playground divide themselves into 10 teams of each.
Okay.
How many different divisions are possible?
Divide themselves.
Yes.
I'm gonna repeat the question, please.
Yeah. So there is a game of basketball. 10 children have to play
Okay.
that game. So they divide themselves
Okay.
into two teams of five each.
Okay. So that means they're having the choice to choose the team.
Uh, Not again, because what is
Okay.
happening? You have the game which is happening amongst 10 people, and two teams, they will divide themselves, but it is like,
It's in each 5.
in five. So, this is the same case. The only different thing is now, because division of two teams is happening, not teams are not pre-decided. Division consists of two groups of five each.
Yes.
So that
Yes.
is also the same. Here in the last question, both of the teams were different because of leagues. Different leagues were there. Here,
Yes.
here there are two same groups also. Anybody can
Okay.
choose anyone, and they
Yeah.
are playing for the same league. So
True.
intra competition is happening. So
Hmm.
that's how they are. We are having two more arrangements. Is this fine?
Yes.
So this is how these questions are a bit, you know, introspectory in nature. You have to see that what keyword can take us where. You see?
Hmm.
Now there can be multiple ways also. Um, Let me give you an example. Tell me how many different seven plates, license plates are possible?
Seven license plates.
Seven place license plates are possible if the first two places are for letters
Okay.
and rest are for numbers.
Are they repeating? Are they like repeating as allowed or not?
It's like different place.
No, are repetitions allowed?
Nothing is mentioned. So
Okay, so then it's like
repetitions,
26 factorial into 10 factorial into 10 factorial into 10 into 10 into 10 factorial. I mean.
so we'll write that there are 26 ways for this.
Yeah.
26 ways are for this. We have 0 to 9. 10 numbers for
Yeah.
this. If repetition is allowed.
Is allowed.
Factorial will not come.
Oh, sorry, a factorial won't be there.
Huh.
Sorry. Mm.
And then if repetition is not allowed, then
26, 25, 10, 9, 8, 7.
perfect. So again, a question. Let's say there's famous rhyming scheme. There's nursery rhyme. I was going to St. Ives. I met a man with seven wives.
Okay.
Each wife has seven sacks.
Okay.
Each sack has seven kittens, seven
Okay.
cats, and each cat has seven kittens. How many kittens did the traveler meet?
How many kittens the cavalry?
Sorry, do you want me to repeat?
Okay. Yeah, please, ma'am.
Ha. So let's say I am a traveler. So I visited the
Okay.
St. Ives. I met a man.
Okay.
This man is
Okay.
having
It's
seven
seven
wives.
wives.
Each wife has seven sacks have seven cats. Each cat has seven kittens. So how many total uh, organisms I have met?
Seven. No, wait. One. 7 into 7 into 7 into 7.
Perfect. 7 is to 4. So it is
Yeah.
the case of repeated permutation.